We move on with the next example called firstprogram.asm. This is our first program which actually is going to do something. It is actually going to have input and output. Let's open this program. We begin by some observation. The general structure of this file is basically the same as the one we have seen for console.asm. Let's open for a moment console.asm just for the comparison. On the left, we can see firstprogram.asm, and on the right, we can see console.asm. The structure is pretty much the same. In both files we have this statement format PE console and also entry start, which corresponds to the label start, which can be found in both source files. We also have include win32a.inc in both files and section text code readable executable in both files. The difference begins after the start label. In the console program, we have those 4 instructions and then we exit the process. Instead, in firstprogram.asm, we have a bit of a different piece of code and then the 2 instructions which exit the process. Finally, the ending of the file is pretty different. On the right, in console.asm, we have the imports section or the iData section. We can see that this section cannot be found inside the firstprogram.asm file. Instead of this section, we have this simple include statement, include training.inc. Now that we have seen the differences, let's discuss firstprogram.asm in a more detailed fashion. We can close console.asm. Maybe the first question would be, where is the iData section? We probably need the iData section if we call the subroutine exit process. The answer is simple. We have the iData section declared inside the file training.imc. As we are not going to have much use or much changes to the iData section during this course, I've decided to put it inside this file training.imc. This way, we can concentrate on the stuff that really matters to us, which is, for example, the code of our program. So what is inside this file, training.inc? First, I want to mention that this file is not part of Fasten. This file was written specifically for this course, and it is going to help you during this course. There is nothing really special about this file. You can always open this file and see its contents. I'm not going to discuss the contents of this file at this point because we don't yet have the tools to understand the contents. But it will do no harm if at this point you open this file and see what is inside. I want to give you a short summary of what is inside training.inc. Training.inc contains, as we said earlier, the iData section, which deals with imports and subroutines from some remote libraries. It also contains a few helper tasks or a few helper subroutines. Those subroutines will help you with input and output. On the first stages of assembly programming, it could be hard to use input and output, especially if you use an operation system. As our program runs inside an operation system, if we want to give output or to get input, we have to ask the operation system to do that. We don't have direct access to input or output. Therefore, we have to communicate with the operation system in some special ways. In the future, you will know exactly how to do this, but at this point, I don't have the tools to explain you how it works. In the end of the course, you will know how it works, but not now. Therefore, instead of using complicated code for input and output, all this complication is encapsulated inside simple input and output functions. We are going to begin with two simple functions called readhex and printeax. Those functions, of course, could be found inside training.inc. Training.inc contains a few of these functions. It has a few more functions to let you send output to the user and get input from the user. The first two functions that we are going to use are those two. Let me explain what readhex does. The readhex function or subroutine reads EAX as a hex number from the console. It means that the user can type in a hex number, and then in some magical way, this number will be inside EAX. Printeax is a function that can be used for output. It allows you to print the value of EAX as hexadecimal to the console, which means that you can print any number that you want. You can put anything that you want inside EAX and then print it to the console. You might be wondering, what is call? Call is a special instruction to execute a function or a task or a subroutine. Those are different words for the same thing. We will not discuss how call works at this point, but believe me, it works. Whenever you want to use readhex or printeax, just write this line. Write this full line. Call readhex. Whenever you want to output something, write this full line. Call printeax. And just make sure to have something meaningful inside EAX before you call printeax. Let's discuss what this program actually do. First, it reads a number from the console. It waits for input from the user, and then it saves the input inside the EAX register as a number. Next, the instruction inc EAX is going to increase EAX by 1. Finally, the current value of EAX, which is just the input plus 1, is going to be printed back to the console as output. I want to deal with this part, exit the process. Why would we add this part? The reason is simple. If we don't add this part of exiting the process, the program will just continue. It will just slide down. And for example, if inside training.inc there is more code, this more code will be executed. We have to stop the execution somehow. And to do this, we use those two instructions, push 0 and call exit process. Make sure to always add those two instructions. Basically, this is how your programs are going to look like. Every program of yours will have this header, and then it will declare the text section, which will contain your code. You will always have this part in the end of the code, exit the process, at least in the beginning. And then in the end, you will include training.inc, which contains the helper functions. Those helper functions allow you to input or output. Let's assemble this program and see what we get. First we save this file, and next we move on to the console. We open a console. Make sure that the console is at the correct path. Then we use the fasem command to assemble this program. Fasem 2 and then the name first program .asm. I press the return key. We can see that we have some kind of error. We already know how to deal with this kind of errors. It says that in line 21 of the file, we have an include directive which cannot be fulfilled because the included file, training.inc, cannot be found. Let's take a look at the source code for a moment. Indeed, we have this include directive in line 21, which says include training.inc. If we want fasem to be able to include this file, we have to specify the location of this file. We already know this. We did the same for the win32a.inc. This is something that we only have to do once. After we do it once, we can just write as many programs as we want with those include files. So don't worry about it. Now let's add training.inc to the include environment variable. Maybe first let's see where this file is. You can find it inside the include folder for this course. And this is the file, training.inc. Now let's add it to the include environment variable. I press the start key, then right click on my computer, properties, advanced system settings, and then under the advanced tab, environment variables. I look for the include environment variable, and this time it is here, because we've already defined this variable before. We can see that it contains the include path for FASEMW. This is what we included for the file win32a.inc. You probably remember. This time we want to add another path. In order to do this, we first write a semicolon, and then we add the path of training.inc, which is just the folder include. I copy this path, and then I paste it here, right after the semicolon. The semicolon separates the different paths where FASEM is going to search for include files. I paste the path, and then I delete the last character. Now I can just click OK. Again OK, and again. And I can close this window. I remind you that if you just try to assemble it again, on this same console window, it will not work, because you have to restart the command line. So I exit, and then I open a new command line. Now I use FASM to assemble this program. This time it worked. We can see in the output that it took 3 passes, 1.4 seconds, and the result is of size 1536 bytes. Let's see what we got. The result is this file, called first program. Let's run it from the console. First program.exe. I press the return key. Now it seems like the program waits for something. And this is reasonable. Let's take a look at the code. In the beginning, we want input from the user. So the program probably waits for our input. Let's give an example input. For example, 3. And then I press the return key. I get the result of 4, which is what I expect because of the increase instruction. Basically what happened is that the program read a number into EAX, then increased EAX, and finally printed the result to the console. Let's try some other numbers. Maybe 23. I get 24. Another example. I can type in F and I get 10 because the next number after F is 10 in base 16. I'll remind you that all of those numbers are in base 16. Now let's try something more interesting. Let's give the number 8 times F. Can you guess the result? You were correct. The result is 0. That is because of the wraparound. The EAX register can contain only 32 bits. Whenever we add 1 to the number consisted only of F's, we get the result of 0. I want to show another example which is more about some technical detail. What happens if I give some input which is not a number, which is not a hex number? Maybe what happens if I give 5 X's and I press the return key? I get 1. This actually means that this string of X's was translated to be the number 0. I just want to mention that if the input that you get is not numeric, which means that it is not a base 16 number, read hex will give you 0 as a result. As we only use those functions, read hex and print EAX, for training, you shouldn't really care about it. But I just wanted to mention it so you will know the exact behavior of this function.